Hello, 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 hello. How are you all doing? Okay, back online, back online. Um, right, guys, we are finished with the calculus and all the mandatory topics, and now our optional. So we're going back to matrices and graph theory. I've decided we'll start with the matrices. Um, yeah. Anyway, we'll start with that one. Now, this part of matrices is it could be a little bit trickier. Um, I don't know. Some people might say more. Some people say it's easier than the one from last year. I'm not sure. I'm not sure. But it's certainly, in my opinion, more interesting. So, and I'm kind of guessing here. If there was a reason why matrices were created, okay, matrices was to, I would say it was to help us solve a system of linear equations. So things like, which you've done in, I think we do it in grade 10. 2x plus y equal 3 minus 3. In fact, let me write it like this, okay? 2x minus y equal, 3. 3x plus y equal 4, okay? So that sort of stuff, okay, that's what we actually create matrices for. And we will see why is that in a couple lessons, not today. So here's a matrix, a 2 by 2 matrix. And what we're going to learn today is to calculate something called the determinant. And if you guys, according to plan, I think you probably did that in grade 10. But whether you did or you didn't, even if you did, you probably forgot. So we'll just remind you from scratch how to do it. And for a 2 by 2, we're going to calculate the determinant of 2 by 2, 3 by 3, and in theory also 4 by 4, even though we're hopefully not going to have to do that because that's taking way too long. So a 2 by 2. What we're going to do is, okay, first of all, how do we write it? Okay, if this is A, okay, this is the matrix A, then the determinant of A, we can sometimes write it like this, just DET, determinant of A. Or sometimes what you will do is you write the determinant itself, okay? But instead of doing these round brackets that shows you it's a matrix, we're going to do a straight lines. So whenever you see a matrix with straight line next to it, hugging it, that means we're actually looking not at the matrix, but we're looking at the determinant of the matrix. Okay? And either way, what we're going to do is we multiply the diagonal elements. Okay? 2 times 1 minus, always minus, and multiplying these two. So minus 1 times 3, which is, how much is that? 2 plus 3 is 5. Okay, you just see that, you can see it all the way there. Yeah. Okay, so the matrix of that is 5. Okay, that times that minus that times that. Okay, now I probably should have said before I did that, what's the determinant? Okay, so as you will see in next lesson, okay, which will be next week, determinant will help us find something called the inverse matrix, which helps us eventually to solve those simultaneous equations that I showed you here. So we're already working towards how to use matrices to solve simultaneous equations. I know you've learned how to do it with the x or y. I should have kept that 2x plus y. You know how to use elimination and substitution. But what about if you have maybe 5 variables, not just 2, x and y, okay? Then it will be much more difficult to do it, and then that's what, this will be a better method, okay? So the question is, okay, let me just pause, clear out, but the question, let me ask it now, okay? What about calculating a determinant of 3 by 3 matrix? Pause here. Okay, so yeah, I've got a matrix here, 3 by 3, but before that, I just wrote here a formula. So if I've got a general 2 by 2 matrix, A, B, C, D are the components, and I want to find the determinant, then it's simply AD minus BC. That's just the formula that needs to sit in the back of your mind. Okay, what happens, what about a 3 by 3 matrix? That's a little bit more tricky. Maybe I'm just going to say it now. There is a way of doing it with a calculator, and that's, I think, fair enough. I think you can use a calculator, not one of those, one of the silver ones. So what I'll do, I'll send you a little video, a separate video that I'm just going to fish out from YouTube that shows you how to do that. It's very, very easy. Right, but obviously we need to know how to do it manually because some of the questions will have X's as the entry. So instead of 3, you might have X, and here another X, and then you need to know how to do it properly. Okay, by hand. Okay, so what do I do here? What I'm going to do here, it's a little bit more complicated. What I'm going to do is I'm going to choose a row. Okay, I'm going to choose a row, and it's actually you can either choose a specific row, one row, or one column, and it is important to know which row is better to choose. But we'll just go through that first row. So I'm just going to choose the first row, and what I'm going to do, I'm going to write these elements. So I'm going to say, okay, 1. I'm going to time this 1. Now, what do we time it by? So what I'm going to do is I've kind of, this is my element 1 in the first row, and I'm going to put a little line through it, horizontal and a vertical line, which I'll have to erase every time. It's a bit annoying. And if you notice, if I take a line through it, horizontal and vertical, then I'm actually left with a 2 by 2 matrix. Can you see that? Okay? That's just 3, 1, 4, 1. So the rule, okay, which we don't have, thankfully we don't have to prove, but the determinant of this 3 by 3 matrix will be 1 times the determinant 3, 1, 4, 1. The determinant of the 2 by 2 matrix, which then I know how to do. Now that would have been nice if that ended there, but unfortunately it doesn't. Okay. Now to that, I need to. Oh, that's going to be a little bit tricky over the time to erase that. So I'm going to get back my matrix. Okay. I just want to make sure that I didn't erase any minuses. Yeah, there was a minus here. So unfortunately, I don't stop here. Okay. Just make sure I've got the right thing. Yes. Okay. Now what I'm going to do is I'm going to take the next element. So that one was the first one. The next one is minus 2. Let's just put him a little bit closer. Minus 2. Okay. And I'm going to time it. What are we going to time minus 2 by? I think you can probably guess. Okay, I'm going to do dotted line. I'm going to again pass a line through that second element. Okay. Horizontal, vertical. And again, I don't know what that number was. Number 9. That's minus 1. Okay. So now, again, once I cross these numbers, I'm end up with 1, 2, 3, 4. Another matrix of 2 by 2. So the rule is I need to multiply minus 2 by the determinant of minus 1, 1, 2, 1. Okay. So just the same as I did here for this element and having these the leftover matrix. Now I'm going to multiply minus 2 by the determinant of the leftover matrix. Okay? But to make, because we always want to make things a little bit more confusing for you, I'm afraid. I'm sorry. But if this was just that times that, now for the second element I need to put a minus. Okay? So I'm going to give names to all these things. I'll give one. I have to. That matrix that left over here, okay, that matrix was left over here, we call it the minor of 1. So each element in the matrix, I might as well just use these words now. Each one of these elements in the matrix has their own minor. The minor of this one is this matrix. The minor of minus 2 is this matrix. Okay? So what we're doing, we're multiplying an element in the row by its minor. But there is a change in sign. Okay, I'll use another color here. Right? For the first element, we use a plus. For the second element, we'll use a minus. Okay? For the third, because there will be a third, isn't it? We're doing a whole row. We're not finished yet. For the third element, it will be a plus. Okay, so now we need to plus. Okay, you see plus. What's the element now? Element is 2. Okay? And we're going to multiply this element by its minor. Remember, I spoke about minors now. What is the minor or determinant of the minor, more precisely? So what is the minor of 2? Well, I'm going to put that line across these two lines. And now I've got this element. Okay? So I'm going to multiply 2 by the determinant of the minor, which is, let's use green, minus 1, 3, 2, and 4. Okay? And that's it. Okay, that's it. Well, not completely it. I still need to calculate the determinant. But in theory, now I've got the full calculation. Okay? So I'm multiplying an element by its minor. An element by its minor. Paying attention that I need to use the right sign. Okay? Let's just finish that first. Okay? Let's just finish that. And we can do it in our head. So it's 1 time. Right, what's the determinant of 3, 1, 1, 4? It's 3 times 1, which is 3, minus 1 times 4, it's minus 1, right? 3 minus 4. So these things just starting to go in your head, right? 3 minus 4 is minus 1. Minus, okay, let's do minus is plus, right? So plus 2 times the determinant of this 2 by 2 matrix is minus 1. Minus 1 times 1 is minus 1. Minus 2. So it's times minus 3. I might be making mistakes here. Hopefully not. Okay? No, here we go. That's definitely a mistake, right? So it's minus 1. That might not. I was right. Okay? So it's minus 1 minus 2. It's minus 3. Yeah. Okay. Plus 2 times the determinant of this. Okay. Minus 1 times 4 is minus 4. Minus 6. What is minus 4 minus 6? Is minus 10. I minus 10. Okay? So, right, let's just do that. So that's minus 1, minus 6, minus 20, we're getting minus 27. Let me just check that we got it right. Okay, so what I want to do now is show you what would have happened. I mean, we chose the first row to calculate this determinant, but I could have chosen the second row, or I could have chosen the third column. It doesn't matter. It works with the same column. Okay, so I'm gonna do the second row, but it's important that you understand it will also work with the column as well. So if I choose, let's say, the third column, then I would say, okay, it's going to be 2 times the determinant of the leftover minor, which is that, once you cross it, it works out the same way. Maybe, I'm thinking maybe I should just use a column just to make sure you understand what happens if I choose a column. So if I choose a column, that means let's write it in a different color. Let's write it in black. Okay? So I'm gonna try and recalculate this now by choosing this column, 2, 1, and 1. So it's going to be 2 times some kind of matrix that I need to find out. Then it will be 1 time a matrix of the minor of 1, and another 1 time a matrix of its minor. And I still haven't looked at the signs. Remember, we have signs, okay? So this one was plus, this was minus, and this was again plus. So let's just carry on and find out what the sign. Each one of these guys have a sign. There's a name for it. I think it's a cofactor or whatever. Don't worry about a name. But it's very easy to determine what the sign is. Look, we always start with plus. We always start with plus. And then we just go plus, minus, plus. Therefore, that's going to be minus. So that doesn't mean it has to start as a plus. Okay? So plus, minus, plus, minus, plus, minus, plus, minus, plus. That's it. Okay? Never, don't ask yourself, what is this about? Why is it coming? Well, you're not going to have to worry about it. Not now anyway. Okay? So now I've got the signs, these cofactors, the signs of these. So this is indeed a plus. I don't have to write it. But the 1 is going to be a minus. Okay? That's going to be a minus. And the last one is a plus. Okay? So all I'm going to do now is fill in, find out what is the minor, because we're timing each element by the determinant of its minor. So we need to figure out the minors. Okay? So I'm gonna, I'm not gonna actually put everything now. I'm just gonna put my hands instead of, that would be more clever instead of drawing and erasing every time. So 2, what is the minor of 2? So I'm gonna put 2 hands. Yeah, it's much better. Why did I do it like that before? So I'm gonna put my erase, like hide the row and the column of 2, and then I'm ending up with this. Okay, so that's going to be minus 1, 3, 2, and 4. Okay? Next time I've got the minus, hang on. Yeah, it's -1. It doesn't have minus here, but it's a minus of a pop factor. Okay? So 1, so I'm going to hide that. And you see I'm hiding that. What am I getting? I'm getting pop, 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 pop. So I'm getting 1 minus 2, 2, 4. And then last element, the 1, okay, I'm hiding this, and now you can see the minor here. Okay? So it's 1 minus 2, minus 1, 3. Okay, let's see if we can do that. 2 times -4 minus 6. All right, -4 times, I'm hoping I got it right. I didn't check here. I don't know if you can see. I checked it for the second row to make sure that I get the same answer, but I didn't check this one, so hopefully it works. -4 minus 6 is -10. This is minus 4. 4 times, okay, so I've got that time that minus that time that, so it's 4 plus 4. And you see that? It's 1 times 4 minus 2 times 2 to calculate the determinant of this. So the minus is a plus. So I'm getting 4 plus 4, it's 8. Okay? But I've got a minus here, so it's -8. Hoping I've got it right. I hope I'm getting the right answer. Plus, okay, that better be because I already have -28, I better have plus 1, -1 here. So 1 times 3 is 3. Okay, so I'll write it down here. So 1 times 3 is 3 minus 2 times -1 is +2, but I've got 3 minus 2. Yes, I think I managed to get it right. Okay, 3. Let's check again. 3 minus. I've got 3 minuses, so it's eventually a minus. 3 minus 2 is 1. So I've got plus 1 times 1 plus 1. And if I'm adding that, -28, -20, -28 plus 1, -27. Thank goodness I got the same answer. Okay, so what was the aim of this exercise, this terrible exercise? To show you that you don't have to choose the first row. You don't even have to choose a row. You can use a column. In this case, I chose a column. You could do the same thing if you're a little bit bored. You can choose the second column or the third row. Okay, every time multiplying an element by the determinant of minor and remembering to have assign the right sign. Okay, I'm going to do one more thing with you before we end. Okay, so here I've got another matrix, 3 by 3, and we want to calculate the determinant. Now you saw a determinant, it took quite a while, but if you're clever, you can calculate the determinant, this one, very, very easily. Now it's all about choosing the right row or column. Okay, as I showed you, you can either choose any column or any row, and use as long as you use the same algorithm, it will work. Now I would choose the second row, and I think it's quite clear for you. Why would I choose the second row? Well, because there's 2 zeros here. Okay, how do I calculate the determinant? Well, it's going to be your first element, which I actually need to find out which sign it is. So let's just put the sign. That's a good habit from the start. You'll start with plus, minus, 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 plus. So in fact, it is going to be -1 times the determinant of its minor. And I'm not doing that mistake again. I'm just hiding like this, and you can see it's 1, 0, 1, 0, 2, 1. And that's it. Right? That's it. You might ask yourself, why not? Well, there's more elements, but these elements are 0. So I'm going to have plus 0 times the determinant of something. I don't even need to find out what's the minor, because obviously 0 times anything will be 0. And the same thing here. Here I'm going to have -0. I'm not going to fill in these things. It's all 0. So I don't need that. It's all 0. I don't care about it. The only thing I've got here is to calculate that. So the moral of the story is you gotta choose the right column. Okay, I could have chosen also the third column. That would work as well. Okay, you want to choose a column or row that has as many zeros as possible, because guys, in theory, I can ask you to calculate the determinant of 4 by 4 matrices. Okay, so if I have, let's say, let's just make something now, 2, 1, 3, 0, 0, 1, 2, 3, 1, 0, 0, let's say 2, 2, 0, 0, 0, 0, 1, 2, 3. Okay, let's just put one more. Yeah, something like that. Okay, now in this case, how do we find the determinant of 4 by 4? Now, I'm not going to go all the way with this. Okay, in theory, you guys should be able to calculate the determinant of 4 by 4 or more. Okay, in practice, probably you can just use a calculator. Yeah, but I want you to know, at least know the process. What is the process to find the determinant? Okay, it's exactly the same as 3 by 3. Exactly the same thing, but there's more layers. Let's start by just putting the signs, okay? So it's the same thing. So, plus, minus, 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 plus, minus. Okay. Now the next thing is you've got to choose a row or a column, okay, that you're going to multiply these elements. So there's a bunch of rows. I mean, I wouldn't choose the first or the second, okay, because I've got rows with more zeros. I would probably choose either the third row or the fourth column, okay? So let's choose the third row. So it's going to be 2 times something. Okay, now, okay, I'm exactly the same way, okay? So I'm going to put my hand over the 2, and now that's the minor of the 2, so I'm going to multiply the determinant of the minor of the 2. So now it's going to be 1, so it's these. It's a 3 by 3 matrix. 1, 3, 0, 1, 2, 3, 1, 2, 3. Yeah, 1, 2, 3. Okay, so that was 3. Okay, so now I multiply this element not by 2, but determinant of 2 by 2. It's by 3 by 3. So it makes things way more complicated. Now, I'm not going to worry about this 0, because 0 times its minor is going to be 0. So I'll only have that one. And that's also plus. So plus 1 times matrix, determinant. Okay, I'm going to find the minor. I'm going to put the line here. And what I'm getting is 2, 1, 0. Right, 2 ones, because I've hit this. 2, 1, 0. 0, 1, 3. 0, 1, 3. Raise this one, and I've got 0, 1, 3, 0, 1, 3. Okay, and that's it. Okay, well that's it. Now I have to calculate the determinant of these 3 by 3, and this. So you can see you've got an extra level. So each one of them is like a question that you had before here. So you can see that calculating the determinant of 4 by 4 is much more complicated. But we seriously simplified it by choosing a row with as many zeros as possible. In fact, I'm just going to tell you now, I'm going to prove it, but I can tell you that these determinants are actually 0. Okay? But never, in fact, I didn't even need to go that way, but never mind. We'll just leave that now. I want to do actually one more question that I can see in the exercise we have, something with when there is x. Okay. Okay, so last thing for this lesson is, and this is the reason why we need to know how to calculate the determinant and not just use a calculator, because sometimes the entries that you have in a matrix are going to be variables. So here we told the determinant of this matrix is 0, and we need to find x. So we need to write an equation here for x. So, I mean, again, it's a thought. What kind of what row would you choose? Unfortunately, I don't have any zeros here, so I can't go find a row with many zeros. But I personally would choose the first row. And why? Why would I choose the first row? Because all the entries, okay, they're not 0, but they're 1 or minus 1. So at least maybe it makes it a little bit easier. Also, I need to remember to put the sign, so it's plus, minus, plus. I'm not going to worry about the rest because I'm not going to go there. So I'm going to write it like this, okay? So it's going to be minus 1 times the determinant, okay, of the minor, which is x plus 5 minus 1, 6x minus 2, minus 1 times the determinant of, what do I have here? Minus 7 minus 1 minus 6x minus 2. And then plus minus 1, so it's minus 1 again, times the determinant of the minor, which is minus 7x plus 5 minus 6x minus 2. Okay? All of that equal to 0. Now I'm going to stop here. You guys obviously have more to go. Now you need to find the determinant of this, but that's no problem. That's x plus 5 times x minus 2 plus 6. Okay? So you find that you write down an equation of x is going to be a quadratic equation of x. You can see there is a x squared. So you're going to probably have more than one solution. Okay? So have fun with that, and I'll see you next lesson.